Hello everyone, in this video we will be learning about feature scaling. So what is feature scaling, why we will be using that one, and what are the different techniques and when to use which technique. So we'll be looking into all these things, and finally we'll be having a small code demo where I'll be showing how to apply these different feature scaling techniques, and we'll be seeing how the performance of an algorithm is increasing. So without wasting any time, let's get started. So what is feature scaling? So let's take an example of a data set which has two features. One is age and the other one is salary. So when you consider the feature age, so the values will be between around like 0 to 110, let's say. And when we consider the salary, the values will be around 0 to 10 lakhs or 15 lakhs or 20 lakhs. So if we see the difference between these two features, the ranges of values will be different, large. Like the age is only between 0 to 100, and when we consider the salary, it is between 0 and lakhs. So there is a lot of difference between these two features. I mean, the range is very different. So when we have a data set which has features highly varying in magnitudes, units, and range, then what we will be doing is, the goal of feature scaling is converting all these features into almost all features into the same scale, or getting all the values into the same range. So this is what feature scaling is. So why we will be using that one? Because we will be having different issues, like we will face different issues when we apply different algorithms on a data set. So one issue will be not giving the equal importance to every feature, and the other will be not converging faster. And we also have the other feature, like the ML algorithms will not process the data properly when we have this data of different scales. So these are all the problems we will be facing. Like I will discuss all these problems in detail in the next slides. So these are the problems we will be facing if we don't apply feature scaling on different algorithms. So let's see how these algorithms will face these issues and how we will be solving that one. So first issue we will be facing is with the gradient descent based algorithms. So if you look at these two pictures, the first one. So if you see, the gradient descent is not moving in the straight way. Like there is a lot of zigzag and randomness in that to find the local minima or global minima. So it is moving in the random directions with the different learning rates, and because of the different scales in the features, and it is not faster in converging. So if you look in the second picture, so where we'll be converging very faster without any randomness or without any zigzags in the path. So this is because of the feature scaling. Because if the features are of different scales, so our gradient descent algorithms will be moving in at very different directions because of the scales of the features. So when we have all the features in the same scale or in the same range, so the gradient descent works best. So it will move in the same direction, like it will move in the same path, finding the local minima or global minima. So this is one issue we'll be facing, and this issue will be faced in algorithms like linear regression, logistic regression, and the neural networks, the algorithms which uses gradient descent as a backend. So we'll be facing this issue. To solve this issue, we will be scaling our features. So let's look at another issue, which is a distance-based algorithms. Like what will be happening here is, so in algorithms, we'll be there are different algorithms where we'll be applying techniques like calculating the distance between the data points. So we'll be using algorithms like Euclidean, the equations like Euclidean distance or Manhattan distance. So where we will be calculating the distance between the 2 points. So here, so let's consider the same example where we have age which has ranged from 0 to 100 or 110. But when we consider the salary, we will be having different scale, 0 to in 10 lakhs or 15 lakhs. So when you apply these distance based algorithms, so what these algorithms will be doing is, they will give more importance to the values which has a high ranges. So this will the problem, like we'll be facing a biased problem here. So that is one of the biggest problems in machine learning, where it will be the model makes decisions based on some bias. So we need to remove this one. So for removing this one, we will be applying feature scaling to scale all the different features. So we will be facing this issue in algorithms like KNN, K-means, and SVM. So this is one of the other problem which we will be facing, and where we don't need to use the feature scaling, because we don't need to use that everywhere. So if we consider distance based algorithms, or if we consider gradient descent based algorithms, so we need to use feature scaling. So, but when we consider naive Bayes or linear discriminant analysis, or the tree based algorithms, where we don't need to apply the feature scaling, because when you consider tree based, it will consider only single feature to split the data set. So we don't need to do feature scaling here. In naive Bayes as well, it will be using all the posterior information and posterior probabilities and everything, so we don't need to feature scale there. And the linear discriminant analysis will be using a complete different approach, so here also we don't need to use feature scaling there. So this is where we don't need to use the feature scaling algorithms. So we have different techniques doing this one. So we'll be looking at two famous techniques called minimax scaling, and the other one is standardization. So in normalization, we have many algorithms, I mean, many techniques. So in those techniques, we will be looking at minimax scaling. So in minimax scaling, what we will be doing is we will be considering minimum value and the maximum value, and for every value we will subtract the minimum value and divide it by maximum minus minimum value. So this is the equation we will be using to scale our features, and if we apply this one, all the values will be range between 0 and 1, because let's say the x is minimum value, so minimum minus minimum is 0, so the numerator will be 0, so we'll be getting a 0 as a minimum value. And if we take the x as maximum value, so maximum minus minimum divided by maximum minus minimum, so it will be 1, so the maximum value will be 1. So the minimum value is 0 and the maximum value is 1 in minimax scaling. But one of the drawback for this technique is it will not uh, handle the outliers perfectly, because if we have outliers which are different from the normal data distribution, so when you apply minimax scaling, all the values will be between 0 and 1, so it will not correctly handle the outliers, and that is one of the drawback. And as I said, the minimum value will be 0 and the maximum value will be 1. So let's see when to use this algorithm. So when we don't know the distribution of that data, or it is not following the Gaussian distribution, so we will be using the minimax scaling. So I mean, we can use that one, and we can also use when the algorithms does not assume about the data distribution. So let's take an example of KNN. So KNN doesn't assume anything about the data. It doesn't assume anything. So we can scale the data using the minimax scaling for the algorithms which doesn't assume anything about the data distribution. Or we also use the minimax scaling for images, where we will be converting the values of images to between 0 and 1. So if you consider CNN algorithms, so we definitely convert all the image values which to lie between 0 and 1. And the other use case, like whenever we want the data to be between 0 and 1, we will be using the minimax scaling. So let's now look at the other technique called standardization. So we also call this as z-score normalization. So in this technique, what we will be doing is we'll be considering the mean value and the standard deviation value. So we will subtract the mean value from a value, and we'll be dividing that with the standard deviation. So by doing this, all the values will be centered towards the mean and with a unit standard deviation. So whenever you apply this technique, all the values will lie around the mean and with a unit standard deviation. So that's what when we apply this algorithm, you'll be getting that one. So in minimax scaling, like when you apply that one to the complete data set, all the features will be between 0 and 1. So but when you apply the standardization, so each feature will be of different scale. because we will be using the mean and the standard deviation, and it can also handle the outliers perfectly. Because we when you apply this technique, it can handle the outliers, because we'll be having the values, uh, uh, I mean, which where we'll be having all the values with the different scales. But in minimax scaling, we'll be having the bounded values 0 and 1. But in standardization, we don't have the bounds. So values can be anywhere. So it can handle the outliers perfectly. The standardization can handle that one. So this is what the standardization technique is. And when we need to use this one, like when we want to ensure zero mean and unit standard deviation, then we will be applying the standardization technique. And if the feature distribution is normal or Gaussian, we can use the standardization layer. I mean, it is not necessarily we'll be doing that one, but if we can do that one, so this is where we can use the standardization technique. And okay, we learned a lot about the theoretical part, but let's see how we can convert the features by applying these techniques, and how the performance will be increasing by scaling the features. So let's look at that one. So let's look at the code part. So first I will be importing some libraries which we will be using. So I just imported that one, and the dataset we will be using the wine quality dataset, where we need to find the quality of a wine. So you can download the dataset from here with this URL, and you can upload that dataset into your Google Colab by just running this cell. So which I already did that one. So here I just loaded the dataset, and when we just visualize the data, so you can see all the values. We have a lot of different independent features and the dependent feature. So if you see the values which are in different ranges, but if you want to see the perfect values of what is the minimum value and what is the maximum value, so when you just run this cell, like dataset dot describe, so you'll be getting this one. So you can understand by, I mean, you'll get a lot of things by just looking at this visualization. So when you just go to the minimum value here, which is around 4.6, and the maximum value is 15. So these values range between 4.6 and the 15.9. But if you look at the other feature, the values lie between 0.12 and 1.58 in the other, like let's say 0.0 to 1, and the other is 0.9 to 15.5. So if you look at all these features, all the values are between different features, I mean different scales. So if you see this one, the minimum value is 6 and the maximum value is 289. So this is a lot different from the all the other features. So we need to scale them when you want to apply uh, algorithms which uses gradient descent as a backend, or the algorithms which are distance based. So what first we'll just apply the algorithm and let's see how it is performing. So I'm just splitting the data set here, and I will be applying the support vector regression algorithm, and I'll just predict the values and look at the metrics, the RMSE metric and the R square metric. So if you see, we got these values like 0.7 and 0.29. This is without applying the feature scaling. So now let's apply the minimax algorithm. So this is how you can create the object for that one, and you will be fitting the extrain algorithm here, and you'll be transforming that data to the train set and the test set. So you just transform that one, all the data is transformed, the training data set and the test data set. So, and when you just visualize this data set, you can see all the values are from 0 and 1, between 0 and 1. Or, and if you also describe that one, describe that data set, you can easily find that one, all the values between the minimum value is 0 and the maximum value is 1. So every feature is between 0 and 1. So this is how the minimax scaling works, and this is the output you get when you apply the minimax scaling algorithm. So let's now just train the algorithm. So we just trained that one, and we predicted the test values, and this is what we got the metrics. So we got the RMSE score is around 0.65, which is good, which performed better than the previous one, and we also improved the R square value here. And now let's see applying the standard scalar algorithm. So we just applied that one and we just transformed the data as well. So if you look here, uh, this one. So when we apply the minimax scaling, all the values are between 0 and 1, every feature. But when we apply the standardization technique, each feature is in a different scale. So if you see, it is from -2, different value. But if you see the mean value, which is around 0, which is around 0, and all values are centered toward that one, and with a unit standard deviation. But if you see the standard deviation here, it is 1 for every feature. So this is what we expected, and we got the result in the same way. So when we just apply the algorithm, so we got the scores as 0.65 and 0.37, which is similar to what we got when we applied the minimax scaling. So if you print all the RMSE scores, so this is for RMSE score for all SVR algorithm without feature scaling. So we got around 0.7. But when we apply minimax, we got around 0.654, and this is for standardization. So we got a better score when we apply the minimax scaling. So you can easily understand, like, if we apply feature scaling technique, the performance can be improved for the algorithms which are gradient descent based and the distance based algorithms. And you can simply this visualize the data with box plot, and you can understand how the data is being distributed. So this is for the original data without any feature scaling. So if you look at this one, so if you look at all this box plot, you can easily visualize how the data is being spreaded. Like, one feature is like from 0 to 300, around 300, and the other one is 0 to around 80, and all the mean values are different, and the data is also distributed in different way. So this is without feature scaling. So but when we apply the minimax scaling, you can see the values range between only 0 and 1, and all the values are between these two values. So but when you look at this standardization, so you can see the mean value is around 0, and all the values are centered towards the mean, and the values of different scales. You can see the first feature is around -2 to around 4 point something, and the other features are around 10 or like that. Like, we got a different scales. So this is how it works, and I hope you learn a lot from this tutorial. I'm sorry if you couldn't understand what I said. I'll try to improve in the coming videos. And thank you so much for watching our videos. And if you are new to this channel, please do subscribe and support us. And yeah, thank you so much.